Welcome to YouTube channel Tech Guru Gautam Prasad. This is a presentation on SF6 circuit breakers. So this is an overview of SF6 circuit breakers. We will explore the basics of SF6 circuit breaker in this presentation. Uh, in this slide, I have tried to show you how SF6 circuit breaker looks like. So these are the circuit breakers uh, installed in a substation. Just take a glimpse of this. Here also, these SF6 circuit breakers have been installed in different configurations. So here there is a substation and SF6 circuit breakers are outdoor units installed in outdoor units. Here also it is outdoor unit. Here also it is outdoor unit. But you can see these are in different constructions. These panels are basically containing uh, the control circuits, and this panel has been shown here on the rightmost picture. As you can see, number of lights it is having. This basically shows you the trip indications and different types of indications it has. Moreover, you can see there is a pressure gauge which measures the pressure uh, inside the chamber of SF6 uh, tank. So basically, this tells you whether the pressure level is high or low, or if the pressure is low, you can infer that the SF6's gas is leaking. So for that purpose, it is given, and lots of control wiring connections, as you can see, they are there. It might or might not have current transformers, voltage transformers, or potential transformers, and different types of relays it has just for enabling different types of trips, as has been discussed in the basics of circuit breakers. Let's proceed. So friends, let's explore what is SF6 circuit breaker. Friends, SF6 circuit breakers use pressurized sulfur hexafluoride, that is SF6 gas, to extinguish electrical arcs, protecting power system by interrupting high fault currents. SF6 gas has a superior insulating and arc quenching properties compared to air or oil. This makes SF6 circuit breakers dominant in high and extra high voltage switchgear market up to 800 kilovolts. So key advantages include its high reliability, a reduced electrical clearance required, and noiseless operation. Though gas leakage can be a concern requiring regular maintenance. So this is the only disadvantage or the problem it has, but it's a big problem to maintain the pressure inside the SF6 circuit breakers. Let's explore how SF6 circuit breakers work. So, in the situation when the fault occurs, arc formation takes place. So when a fault occurs, the circuit breaker's main contact separates, transferring the current to arcing contacts. Arc quenching. As the arcing contacts open, a high intensity arc forms, and pressurized SF6 gas is then directed onto the arc through the nozzles. Next is electron removal. The SF6 gas, being electronegative, attracts and removes free electrons from the arc, and that sustains the arc. So, as because it absorbs the free electrons, that causes the arc to sustain for a longer time, the arc extinguishes rapidly because its free electrons are absorbed very quickly by SF6 gas. So this property of SF6 gas makes it very, very much suitable for this type of high voltage circuit breakers. Arc extinction. The arc is quenched when SF6 gas cools the arc and removes electrons, allowing the circuit to be interrupted at the natural current zero. So in the AC circuit, as you know, the current passes naturally through the zero level. So when this passes through this zero level naturally, the circuit breaker is disconnected or interrupter is made to operate. So thus contacts are separate and the arc is quenched at the same time. Let's proceed further. So how SF6 circuit breakers work, this has been shown in this picture. The displacement of the moving contacts, as you can see in this picture, there is a moving contact and there is a fixed contact. As you can see, these contacts are fixed contacts and these are, moving contacts. So this is a moving member. This entire thing is in contact first with these fixed contacts, but as soon as the fault occurs, this entire thing is pulled back in this direction, left direction, and the whole thing comes, is disconnected. The whole thing, whole moving member comes back and this is disconnected. So insulating rods for operating or moving the moving member. So these are the contacts. This one is contact. This one is contact, and arcing horn. This in the middle of these two contacts, basically we have a arcing horn. So arc chamber is this. This entire whole thing is called the arc chamber, and SF6 gas is pushed from this direction to quench the arc. So the picture itself is self-explanatory, and in the subsequent slide we will see, with the help of animation, how this entire thing happens. The displacement of the moving contacts is synchronized with the valve which enters the high pressure SF6 gas in the arc interrupting chamber at a pressure of about 16 kg per centimeter square. The SF6 gas absorbs free electrons in the arc to form relatively immobile negative ions, and this is arcing contact separation. The loss of electrons in the arc builds up enough dielectric strength to extinguish the arc circuit breaker when the circuit breaker opens. And this process reduces the pressure of the SF6 gas up to 3 kg per centimeter square. So there is an appreciable reduction in the gas pressure from 16 kg per centimeter square to 3 kg per centimeter square. Now the question arises how this pressure is again built for the next operation of the circuit breaker. So thus a low pressure reservoir stores this gas. This gas at 3 kg per centimeter square is stored in a low pressure reservoir, and this low pressure gas, sorry, is pulled back to the high pressure reservoir for reuse. So there is a mechanism to pull this low pressure SF6 gas into the high pressure chamber uh, uh, with the help of some high pressurizing chamber. So basically 3 kg per centimeter square of SF6 gas is converted into again 16 kg per centimeter square pressure gas. So here I have tried to show you with the help of animation how the whole thing, the context separation takes place. So this is your nozzle basically, and these are the fixed contacts. Uh, these are the fixed contacts. This one, these are also the fixed contact. This also contacts has the nozzle, and this is separating SF6 gas compresses and comes out of the nozzles, and the moving cylinder, the whole moving cylinder, uh, moves on this orange color cylinder. So this is fixed piston kind of thing, and on this piston kind of thing, this whole cylinder is moving for the contact separation of SF6 breaker. So this is how this contact separation and extinction of the arc is done. So I hope the mechanism of arc quenching and the separation of contacts is uh, clearly understood to all of you. Now, what are the key features of SF6 circuit breaker? Let's try to understand. So, friends, it has superior properties. SF6 gas has excellent dielectric strength, arc quenching capacity, and non-flammable and chemically stable gas. Second thing, high voltage applications. SF6 breakers are used in power stations and electrical grids, particularly for high and extra high voltages up to 800 kilovolt. So, appreciably high reliability. So, for reliability is concerned, they offer this SF6 circuit breakers offer high reliability and can perform various duties such as switching, unloaded transmission lines, and transformers as well. Compact design. The high dielectric strength of SF6 gas allows for reduced electric clearance, leading to more compact designs. Compact means smaller in size. So as compared to other circuit breakers, SF6 circuit breakers are smaller in size. Types of SF6 circuit breaker. Several types of SF6 circuit breakers exist in the market, varying in their arc quenching mechanism. So we have single pressure popper. In this common design, a piston attached to the moving contact compresses the SF6 gas as the contact opens, and this forces a blast of compressed gas over the arc. So, as we have seen in the last animation, how it was happening. Now we have double pressure. This older design uses high pressure and low pressure chambers. A blast of high pressure gas from one chamber is released into the other to cool and extinguish the arc. And there is a non-puffer design also uh, for the SF6 circuit breakers. The most basic design, which relies on the heat of the arc created, creates a high pressure gas flow without a piston mechanism. So this is the simplest form of the non-popper type of the circuit breaker. SF6 circuit breaker are the most rudimentary level of the circuit breaker. Now let's explore what are the advantages of SF6 circuit breaker. Friend, you, Friends, you must have understood what are the advantages. So non-flammable gas, SF6 is non-flammable gas. The gas is non-flammable, eliminating the risk of fire or explosion during the operation of the circuit breaker. No current chopping. The interruption occurs at the natural current zero, avoiding problematic current chopping phenomena. So, this is self-explanatory as the contact separation is taking place at natural current, zero current, so it avoids any kind of current chopping phenomena. Reduced maintenance. SF6 circuit breakers typically require less maintenance compared to other types of the circuit breakers. Now, SF6 circuit breakers also have a few demerits or disadvantages. Gas leakage is a problematic area. A potential issue is a gas leakage, which reduces the internal pressure and the arc quenching capability of SF6 circuit breakers. Environmental impact. Although SF6 is a stable gas, but SF6 is a potent greenhouse gas as well. And managing its emission and potential leaks is crucial. So that's a challenge when you are using a SF6 circuit breaker. So, friends, thank you very much for listening this presentation till the last slide. Hope you enjoyed the whole journey, knowing about SF6 circuit breakers. If you liked it, don't forget to give a thumbs up. And if you want to ask any question, you may ask it in the comment section. I would like to reply to your question as early as possible. So if you find it applicable to some of your friends, do share this presentation with your friends. And if you are not subscribed to this channel yet, I will recommend you to subscribe to this channel to get such uh, important videos notification. Thank you so much.